I'm Dr. Brenda Parker. I'm a biochemical engineer, and I'm also the director of the MSc Biointegrated Design program that links sort of biology and architecture, and that's hosted at UCL between the Bartlett School of Architecture and Biochemical Engineering. For the past few years, we've been working on projects with the Bartlett where we've been trying to incorporate elements of biology. So whether that's using algae to clean up water or developing biomaterials. And one of the things that we've always encountered is the challenge of scale. So these projects are interesting, perhaps at a very sort of petri dish level, but how do you translate that into something meaningful? And I think with the agenda that we have at the minute, the environmental agenda, with climate change, it sort of became really urgent that we created a forum for people to really work on this in a dedicated way and give them the resources to do so. So as I said, I'm a biochemical engineer. So what I'm interested in is how do we apply biology to solve problems? How do we manufacture with biology? And sort of natural partnership with that is architecture, because architecture is really all about scale and the built environment. So when you put the two things together, both of our ambitions align, so we both want to make things big. And we decided to start this program called Biointegrated Design, where we would take people and give designers a foundation in the biological tools and techniques that they needed, but we'd also welcome kind of scientists and people with a technical background, and also show them some of the design approaches. So it's a really interesting kind of intermingling of the kind of two kind of approaches or schools of thought. But for us, the kind of problems that we're dealing with are such kind of wicked problems. There's not one approach that's going to work. So a purely engineering approach might find a solution that's not very interesting from a social dimension, or it's not very workable or practical. Perhaps a design approach might miss some of the technical nuances or the performative aspects. So we felt, why don't we just make it as difficult as possible and try and combine the two? So in terms of integrating the design with the biology, I think both sets of communities have a different language to learn when you approach these kind of problems. And certainly perhaps people who've been massively put off science in high school have to learn to love it, and have to learn that really a lot of the terminology and sort of perhaps the tools that we use are not as daunting perhaps as they first seem. And really what we've seen when we started this program is once people care passionately about a subject, or they feel very strongly about a certain approach, learning the biological tools is actually quite straightforward. And the most wonderful scientists are actually architects, because they really think in systems, and they are very good at sort of planning and strategy. So even though time management isn't always, biology has its own time frame. It's been a really interesting experience putting sort of non-typical scientists, or people with a non-typical background into a scientific lab and understanding how they relate to that science. And because there is this architectural agenda beyond, making something that's cool or sort of economically viable, we have maybe grander things on our mind. So thinking about how we can adapt to climate change within the built environment, how can we reduce emissions associated with the construction industry, how we can secure kind of like safe and clean water or recycle nutrients. These are really big, as I say, systems problems. And that's why I think sort of putting the biology together with the architecture is the right companionship in terms of scale. One of the coolest projects we've been involved with recently is one that we won a competition called the Water Design Challenge with. And this is a project we've called Indus. And it's really about trying to understand how we can make use of this amazing capacity of microalgae to absorb heavy metals or detoxify wastewater, and how we can bring this into perhaps vernacular architecture of kind of like sort of small scale artisan manufacturing industries. So with a PhD student of mine, Shneel Malik, and with Marcus Cruz from the Bartlett, we have come up with a design that looks at how to immobilize algae and sort of build this into kind of tile geometry, so we can then which is highly customizable, And what's really exciting is we've done the lab tests, so we show its performance. It's able to take up things like heavy metals like cadmium. But we've also tried to build kind of demonstrators, sort of a stage before the prototype, if you like, and try to understand how we can use maybe artisanal sort of manufacturing techniques with the digital and computational and biological research that we've been doing. So that's ongoing. But it was really cool. We got to go to New York recently and exhibit our sort of prototype design that we had. And yeah, we've had some really interesting feedback, especially from people working in the textile industry who acknowledge there are certain problems to do with wastewater. It's not always easy to manage in a centralized way, especially when you have these kind of small scale industries. But it's about combining kind of really sound science with good design, but also with the human interaction. So we went out into the field to India. We met some of the stakeholders who might be, you know, the kind of people who would use this or apply it, and really tried to understand how it would fit with their lives. And then we went back to the lab and started our research. So it's a very different thought process where you begin with the user and then you go back to the lab and look at where the science fits with that so there's amazing backwards and forwards between the design and science agendas, where the design is constantly challenging the science and the engineering and saying, look, I need it to perform like this, otherwise people won't use it, or I need it to activate in this time frame because this is how people live their lives. And for me, this is, as a science, you know, as a person working on the biochemical engineering side, this is such a fun challenge, because previously we would develop something and we would say, look, here is this algae, it can absorb this amount of heavy metal in this time. And then they would have to come up with a design to accommodate that. This is a much more interactive process. And I think for me, that's how I really enjoy working.